This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
Imagine a world where you can spin up a cutting-edge AI assistant without ever seeing a dollar sign on your bill, where every piece of data you feed stays under your own roof, and where the very machines that run your models belong to the same community that built them. That is the reality unfolding right now in Lagos, Nairobi, Accra and beyond, thanks to a new kind of internet, one that puts the power of inference in the hands of African developers instead of a handful of distant data centers. The engine behind this shift is ChainMind, Africa's first decentralized AI inference network. It isn't just another cloud service, it is a living marketplace of compute, a network of everyday computers that have been turned into AI workers. Each one earning native IQ tokens for every token of text they process. In the next few minutes, I'm going to walk you through why Nigerian developers are flocking to ChainMind, how the technology actually works, the concrete problems it's already solving, and exactly what you need to do if you want to join the movement. First, let's unpack the core idea that makes ChainMind different from any traditional AI provider you've ever used. At its heart is the concept of a decentralized physical infrastructure network, or DePIN for short. Think of the internet's early days, when individuals ran their own web servers and the web was a patchwork of personal sites. ChainMind is bringing that spirit back, but for AI inference. Instead of sending your request to a massive, corporate-owned data center in Virginia or Singapore, your request is broken into small jobs and dispatched to the nearest node that has spare GPU or CPU capacity. Those nodes can be a developer's laptop, a small office server, or a rugged edge device tucked into a farm's control room. The network automatically matches each job to the most appropriate node, balancing load and keeping latency low. Because the work is happening locally, the round-trip time for a query from Lagos to a node in the same city can be a fraction of what it would be to a US-based endpoint. Early benchmarks from the ChainMind team show a 30 to 40% latency improvement for West African traffic, and that difference is felt instantly. When a user asks a chatbot for a loan balance or a farmer requests pest control advice. Now, speed is only half the story. The second pillar of ChainMind's appeal is the way it rewrites the pricing model. Most APIs charge in US dollars, and every developer in Nigeria has to wrestle with exchange rate volatility, hidden conversion fees, and the mental overhead of budgeting in a currency they don't earn. ChainMind flips that script by offering an OpenAI-compatible API that bills you in Nigerian Naira. The syntax you use, the endpoints you call, the way you count tokens, everything feels familiar. The only thing that changes is that the cost appears on your invoice as a clean Naira figure. No surprise spikes when the Forex market moves, no need to maintain a separate USD wallet, no extra step of converting tokens into local currency before you can pay the bill. For a startup founder trying to forecast cash flow, that predictability is a game changer. It means you can allocate a fixed portion of your monthly revenue to AI services without fearing that tomorrow's rate will eat into your runway. But the real breakthrough for many developers is the privacy-first architecture that ChainMind enforces by design. In a conventional cloud setup, your data travels across international borders, lands on servers owned by a third party, and sits there, sometimes logged, sometimes cached, until the provider decides to delete it. In Africa, data sovereignty is not just a buzzword. Regulations like Nigeria's NDPR and the African Union's data sovereignty frameworks demand that personal and commercial data stay within national boundaries. ChainMind's distributed model respects those rules because the inference happens on nodes that can be physically located in the same country, or even the same city, as the data source. The request is encrypted end-to-end. The node receives only the encrypted payload, decrypts it in memory, runs the model, and then wipes any trace of the raw input as soon as the job is done. No logs, no persistent storage of user queries, just transient tensors that disappear the moment the response is sent back. Quarterly audits and the open-source nature of the node software let anyone verify that there are no hidden backdoors. For a fintech company handling sensitive financial records or a health startup processing patient data, that guarantee removes a massive compliance hurdle. All of these technical advantages start to make sense when you see them in action, and that's where the real excitement for Nigerian developers begins. Let me walk you through 3 concrete use cases that are already live on ChainMind, each one showing how the network solves a problem that traditional cloud services simply can't address as efficiently. The first example comes from a fintech startup in Lagos that wanted to provide 24-hour customer support on WhatsApp in 3 languages: English, Yoruba, and Hausa. Building a multilingual chatbot on a public cloud would have meant paying for high-latency calls to a US endpoint, and every message would have incurred outbound data charges that add up quickly in a country where mobile data is expensive. By deploying a large language model from ChainMind's catalog, Mistral, fine-tuned on local banking terminology, the startup runs the inference on nodes operated by fellow Nigerian developers. Each time a user asks, "How do I reset my PIN?" the request travels to the nearest node, the model generates a response in the user's preferred language, and the answer is sent back in milliseconds. The startup pays per token in Naira, which translates into a predictable monthly expense, and the node operators earn IQ tokens for every interaction they process. The result is a seamless, low-cost support experience that feels native to the user and builds a small but growing ecosystem of token earning developers. The second story is about agriculture, a sector that feeds the continent but often suffers from limited connectivity and a lack of real-time expertise. In the Sahel region, a cooperative of smallholder farmers needed AI-driven advice on crop rotation, pest control, and market pricing. Traditional cloud AI would require a constant internet connection to send satellite images or sensor data to a remote server, an unrealistic expectation for many farms. ChainMind's edge nodes are placed on modest computers at local agricultural extension centers. During periods of low bandwidth, the nodes run the model offline, processing locally stored data and generating recommendations. When a stable connection becomes available, the results sync back to a central dashboard that the cooperative's managers can view. Because the inference never leaves the country, the data remains compliant with local regulations, and the farmers receive timely, actionable advice without the latency of a transcontinental round trip. The cooperative even incentivizes its tech-savvy members to run nodes, rewarding them with IQ tokens that can later be swapped for cash or used to pay for additional AI services. The third example comes from the mobile money ecosystem, which handles millions of transactions a day across Nigeria. Fraud detection is a race against time. If a suspicious transaction isn't flagged within a few hundred milliseconds, the money can already be gone. By routing each transaction through ChainMind's inference layer, the provider can score the risk of the payment on a node located in the same data center as the transaction gateway. The model, trained on historical fraud patterns, returns a confidence score in under 100 milliseconds, allowing the system to block or flag the payment before it completes. The provider pays only for the compute used, again in Naira, and the node operators earn IQ tokens proportional to the volume they handle. The network's geo-aware scheduler ensures that high-throughput workloads are spread across many nodes, preventing any single point of failure and keeping the system resilient even during peak usage periods. If you're wondering how you can jump into this ecosystem, the process is deliberately simple. First, you sign up on the ChainMind portal and generate a free API key that is tied to your Naira-based account. The dashboard walks you through creating credentials, and you can start testing immediately with the familiar OpenAI SDK or even a quick curl command. Second, you choose a model from the catalog. Llama 2 for a balance of performance and cost, Falcon if you need raw speed, or a specialized fine-tuned model that the community has published. The platform also plans a model marketplace where developers can upload their own fine-tuned versions and earn royalties each time someone calls them. Finally, you integrate the endpoint into your application, monitor usage in real time, and watch the IQ tokens flow to the node operators you've chosen to support. If you have spare compute, maybe an idle GPU in your office or a powerful desktop at home, you can install the lightweight node software, register your machine, and start earning IQ tokens for every inference job you process. Those tokens can be swapped for stablecoins, converted to fiat, or used to pay for your own future AI calls, creating a self-sustaining loop of value. But here's the part most people get wrong. They think the real benefit of ChainMind is just cheaper compute. In reality, the network is reshaping the very economics of AI development on the continent. By aligning incentives, paying developers in a token that they can immediately use to offset their own AI costs, you're not just saving money, you're building a shared infrastructure that belongs to African innovators. This community ownership means that when a new challenge emerges, whether it's a sudden surge in demand for language translation during an election or the need for on-device AI in remote health clinics, the network can scale organically because the people who need the service are also the ones who can provide the compute. It's a virtuous cycle that traditional cloud providers can't replicate because their profit model is based on extracting value from the same users they serve. Scalability and performance are baked into the design. The network's routing algorithm continuously measures latency, node availability, and GPU load, then directs each request to the optimal node. If a node goes offline, the system instantly reroutes traffic to the next best candidate, ensuring that there is no single point of failure. This distributed resilience is especially important in regions where power outages and network instability are common. By spreading the workload across many small participants, ChainMind reduces the risk of a catastrophic outage that would cripple a centralized service. Moreover, because each node processes jobs locally, the data never needs to travel far, cutting down on bandwidth costs and further improving response times. Security, too, is not an afterthought. Every request is encrypted with TLS from the client to the node, and the node itself runs the model inside a sandboxed environment that isolates it from the host operating system. After the inference completes, the node discards all raw inputs and intermediate tensors, leaving only the final response. The open-source nature of the node software means that anyone can audit the code, verify that no data is being logged, and even contribute improvements. Quarterly third-party audits add an extra layer of trust, and the transparent tokenomics give participants visibility into how rewards are distributed across the network. Looking ahead, ChainMind is already laying the groundwork for the next phase of growth. Hybrid compute pools will let developers combine on-premise GPUs, like the ones you might have in a data center or a